Hello and welcome to week 3 in geometry. We are going to start with a warm-up, but before we do that, I wanted to remind you to make sure you've got your math notebook out. I do want you to be taking notes as you go through the recording this week. I will look for your notes when I grade your notes from week 3 that you submit at the end of the week. I'm going to look to see that you have notes from this recording. The reason I ask you to take notes is taking notes makes you more of an active learner as you are watching this recording versus just putting your feet up and watching the recording, which would make you more of a passive learner. You will get much more out of this if you are taking notes as the recording progresses. And remember, you've got that great opportunity of clicking that pause button so that you can take notes and then clicking play when you want to return back to the recording. So let's start with a warm-up question that I do want you to complete in your math notes. So I will look for the warm-up question when I grade your week 3 notes this week. Taking a look at the warm-up question. I'm going to add some things here to this figure before we get started. So I'm adding arrows onto the sides of this quadrilateral. What do those arrows mean? Before we jump into the warm-up, what do those arrows mean? So remember, it's important that we understand the symbols that we put on figures because they're giving us important information. In this case, if we have arrows, it means that the sides are parallel. So see how this side only has one arrow and this side over here also only has one arrow? That means that this side here is parallel to this side. This side has 2 arrows and this side also has 2 arrows. That means these 2 sides are parallel. So we have 2 sets of opposite sides that are parallel. So what kind of shape are we working with? If you said parallelogram, you are right. So I'm giving you some hints to get started here. So taking a look at this parallelogram, I want you to solve for y. I want you to solve for y. And remember, in order to solve this problem, we need to think back about the properties of parallelograms that you've learned so far. And one of those properties is going to help you set up an equation that will allow you to solve for y. So go ahead and click pause and try this on your own. And then when you are ready to check your work with mine, you will click play. All right, so what do we know about parallelograms that's going to help us solve this problem? We already talked about, one of the things we know is that opposite sides will be parallel. That's not going to help us solve this, not this problem. What else do we know about parallelograms? We know opposite sides are congruent. Opposite sides will have the same measurement. So opposite sides are going to be equal. This is going to allow us to set up an equation then. So since we're solving for y, we're really only going to focus on this side and this side. This side, the other 2 sides have x's. That's not going to help us solve for y. So because we know this is a parallelogram, we also know that opposite sides are congruent. So I can say then that 4y minus 3 must be equal to 2y plus 7. Now I've got a nice algebraic equation that I can solve for y in. So I'm going to work on getting all my y terms on one side of my equation and all the constants on the opposite side. So I'm going to move this 2y. I'm going to get the y's on the left side and move all the constants to the right side. So I'm going to move this 2y by subtracting 2y from both sides. And what do I left with? I'm left with 2y. 4y minus 2y is 2y. And I still have that negative 3 hanging out on the right side. My y is canceled out on the right side, and I'm left with just 7. So now I want to work on getting y all alone, so I'm going to move that 3, that negative 3. So to get rid of that and move it to the other side, I'm going to do the opposite of subtracting. I'm going to add that 3 to both sides. Now on the left side of the equation, I'm left with just a 2y. And set that equal to 7 plus 3 is 10. I'm one step away from solving 2y, so I got to divide each side by 2 to get y all alone. Y is going to be equal to 10 divided by 2, which is 5. So my final answer right here is that y is going to be equal to 5. And And the problem just asked me to solve for y. I always want to look back and make sure, did I solve what the question asked me to? It just asked me to solve for y. I did that down here, so we are done. Sometimes maybe a problem might say find a length of a side. Once you found a variable, then you can plug it in and find that length. But what I'm reminding you is to make sure that when you're done, you go back and reread what the question was asking and make sure that you answer all parts of that question. All right, I'm going to move on to the next slide. So if you need more time on this slide, go ahead and click pause. Maybe you need more time to take notes. If you do, click pause. This week, you are going to start the week with taking the Unit 5 quiz. So we are about halfway done with the unit, and it's time for a check-in with a quiz that covers the first 4 sessions in Unit 5. So that would include looking at lines and slopes. We started the unit, remember, with a review of lines and slopes, and if you are given the slope of a line and 2 points of a line, writing the linear equation to represent the line. We looked at parallel and perpendicular lines. We focused on what slopes parallel lines will have. Remember, if you've got a parallel line, the slopes will be the same. If you've got a perpendicular line, you can look at the slopes and tell if 2 equations represent a perpendicular line by focusing in on those slopes, and the slopes will be opposite in sign. One will be negative, one will be positive, and reciprocals. So remember, reciprocal is like a fraction that you flip upside down. And then we looked at properties of polygons, how to find the sum of all the interior angles of polygons. We looked at the exterior angles of polygons and how to find the sum of exterior angles, individual exterior angles. And then we moved on and focused on our first type of quadrilateral, which are parallelograms, and what makes a quadrilateral a parallelogram. And we learned all the different properties of parallelograms, such as opposite sides being parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. So all those concepts will be on the Unit 5 quiz. And remember, a great way to study for the quiz is to go back and redo any low-scoring assignments from sessions 1 through 4. And then we're going to move on to Unit 5, Session 5, which is conditions for parallelograms. So how can you use the properties that we learned about parallelograms to prove that a quadrilateral is a parallelogram? Some properties of parallelograms So I did want to review what are all the properties of parallelograms that we've learned about. So first of all, parallelograms are always quadrilaterals. They're going to have 4 sides. Parallelograms are always going to have 2 sets of parallel sides. Again, pay attention to the notation. They're arrows. Arrows on the sides mean that the sides are parallel. Let's go right under there with the ticks. Remember when we have ticks on our sides, what that means? Well, in order to be a parallelogram, opposite sides are congruent. So the same number of ticks lets us know that those sides are congruent. What about angles? What did we learn about angles of parallelograms? Opposite angles are going to be congruent. So if we have a parallelogram, the opposite angles will be congruent. Note there's one arc here and one arc here. That means these 2 angles are congruent. This angle has 2 arcs. That means these 2 would not have the same measurement, but any arc that also has 2 arcs would be congruent. We also learned that if we draw in the diagonal, so if we go from one vertex to the opposite vertex, that's a diagonal, that line that connects those vertex. So if we have 2 sets of diagonals drawn into our parallelogram, those diagonals are going to bisect each other. So remember when we say bisect, that means that it cuts a segment into 2 equal parts. So you can see that the segment from here to here would be congruent from the segment from here to here. And same with the other diagonal. And then last but not least, we learned that parallelograms will have adjacent angles that are supplementary. All right, so I'm going to move on to the next slide. All right, so let's take a look at a problem. This problem is pulling from the concepts that you're going to learn from Unit 5, Session 5. So just a heads up for that. So we are trying to determine if a quadrilateral is a parallelogram. So in this problem, we are given vertices of a quadrilateral. We're given 4 vertices, and we want to determine if that 4-sided figure is a parallelogram. So how are we going to do that? Well, let's start with first plotting our points. That's a good place to start. So we're given 4 vertices. Let's plot those points. The first one is A is at -3, 2. So let's plot that, mark it with an A. That's point A. B is at 2, 2. We're going to plot that and mark it as a B. C is at -5, -1. I'm going to plot that point, C. And then our last point, D, that we're plotting is at 0, -1. So looking at these vertices, we can connect our points. So let's go ahead and connect those. I'm going to do the best I can to do them as straight as I can. It's not super easy all the time with the tool I'm using. So looking at this, it looks like it might be a parallelogram, but we can never assume anything in geometry. We always have to back up our reasoning with foolproof, concrete reasonings. We want to have something that we can prove that this is a parallelogram. So what can that something be? Well, didn't we learn a lot of properties about parallelograms? We did, and we just reviewed all those. So let's use one of our properties to prove this is in fact a parallelogram. So what do we know about the sides of parallelograms? We know that opposite sides are congruent. So one thing that you could do is find the distance between your 2 sets of opposite sides. And we can use the distance formula. That's kind of a lot of work because we would have to find the distance from A to C, the distance from B to D, make sure those are same, and then find the distance from A to B and C to D and make sure those are same. That's a lot of plugging information into the distance formula. However, you can do it because that is one of the properties, and if you are able to prove the opposite sides are congruent, you've proved it's a parallelogram. What is another thing we know about parallelograms? We know that opposite sides are parallel. And this one is what I'm going to use to take a look at this. So opposite sides of parallelograms are parallel. And what do we know what do we know about the slopes of opposite sides? We learned this back at the beginning of Unit 5. We did some review from algebra. Parallel lines will have the exact same slope. They'll have the same rise over run. So we can figure out the slope of both of our lines, our opposite sides. So let's first focus on, let's do a darker color here. This side here, AC, and the side opposite of it, BD. What are the slopes of both of those sides? So let's start with side AC. What is the slope of side AC? So remember, slope is rise over run. I'm not sure why my screen keeps zooming like that. I apologize for that. I'm trying to catch it. So slope is rise over run. So let's go from this point C and see how many units up and to the right we go to get our slope from C to A. So to go to C to A, I rise 1, 2, 3. So I'm going to have my numerator is going to be 3 for my slope, and then I have to go to the right 2 places. So from C to A, that line has a slope of 3/2. Now, if this is a parallelogram, we need to have that same slope when we go from D to B. So let's check it. So from D to B, we go rise 1, 2, 3, and then we go to the right 1, 2. So it also has a slope of 3/2. That is a good thing. Now we need to look at the slope between A to B and C to D. And we have a horizontal line for both those, don't we? Our 2 sets of remaining opposite sides are horizontal lines. What do we know about the slope of horizontal lines? If you want, you can do a quick web search, but the slopes are 0. And since we have two sets of horizontal lines, we've got from A to B, this is horizontal and this one is also, we've got a slope of 0. So what does that tell us about both of our sides, our opposite sides here? Both pairs of opposite sides have the same slope. So because both sides, opposite sides, have the same slope, we know that this is in fact a parallelogram. We've proven it. We didn't just look at the four-sided figure and say, it looks like a parallelogram. We took it a step further and we used the slopes to verify that it is in fact a parallelogram. All right, so that is a wrap for the week 3 recording. Remember to make sure that you do some reviewing before you take the Unit 5 quiz this week. And now we're ready for the week 3 key phrase assignment. So this week's key phrase assignment, there are 2 parts to it. We talked and reviewed some symbols this week. We see a lot of these different symbols when we're looking at the different sides of figures, and I just wanted to make sure everybody is clear on what these symbols mean. We did review that in this recording. So for number 1, what do these symbols mean? When you see these ticks on the sides of a figure, what do those ticks represent? That's number 1. And then number 2, you need to tell me, what do these arrows represent? When you see arrows that are on the sides of a figure, what do those arrows represent? And that is your 2 questions that you need to answer for this week's key phrase assignment. I hope you guys all have a fantastic rest of the week, and let me know if you need any help with anything this week.